Welcome you all for this on grid compliance study. Like we have 2 different grid codes and even 3 different grid codes, and I thought of taking with Saudi and then probably moving to, if time permits, moving to some other grid codes. What we are going to talk about is grid code compliance. What is grid code? Why grid code? What's a specific? So, and probably this grid code also has given some, detailed objective and scope of this grid code, what is covered, what is not covered, and how to implement it and how to enforce it, right? Grid code cannot be implemented without some enforcement. If you are asking independent power producer to maintain the harmonics, he will not be happy. If you want to maintain certain fluctuations or ramp up, ramp down or LVRT, he will not be happy because that increases his cost. Objective of independent power producer is to increase the generation so that he can make more revenue. So then why grid code is needed? If you allow all the independent power producers to produce the power at their will and with whatever maybe the impact on the grid is not studied, the grid is not really going to be stable, right? Like that's the reason why we need a grid code. So whenever there is a new source or a demand which comes to the grid, which has an impact on the grid, we need to study the impact of the new addition or a modification, and this should not add anything harmful to the, it should not create any harmful to the existing grid and its operation, right? So that's the reason why like we have a grid code, and how to comply that we are going to talk about. So how to implement that they have given, and of course if there is a dispute, obviously when there is a dispute between independent power producer and the transco, or transmission utility, transmission state utility, or whomever it is, how to solve these disputes and some unforeseen circumstance if there, and like where we can probably suspend this grid code, what is like partial invalidity, force majeure, like generic, all these things which is given. Like I will probably, if you want, I can share this document and it is available, downloadable in the internet. You can download it also. And 99% of the countries, this grid codes are open, like you can download, right? Like we have taken Saudi, but like if you take any countries, you can download. I'll also probably go through at the end, like from where you can download the various countries grid codes, right? Fine. So that's like a general about the grid code, which we are not really going to talk much. That's the reason why we are talking about the index itself. What's the connection code? What's the grid connection procedure? Like if you want to connect with the grid, what are the procedures which you need to do, right? So I'm not really sure how many of you have worked in US market. If you're working in US market, probably when you need a grid connection, first you have to probably put up the application. You will be submitting some forms. There you might be mentioning some details, and then this grid connection request has been probably go in a queue, right? And they will evaluate it. They will approve the preliminary this one. Then they will ask some additional information for the next level. And probably if the project is matured, then they will like go with some other additional requirements and stuffs. So what are the procedures for grid connection, and like what are the grid impact study which we need to do? So let's quickly jump onto this, and probably coming back to this same page number 3 little later. Let's look at what's grid impact studies, TSP. And probably when you're going through this grid code, probably these abbreviations are really important. Any idea what is TSP? TSP shall develop and maintain set of required technical planning studies for evaluating the impact of on the grid of any proposed connection or modification to an existing connection. Transmission system provider, I guess like that's TSP. Probably we can check. Yeah, it's a transco. It's a transmission service provider or transmission system provider. Like we need to check what is the abbreviation. We will look at that little later. So it's the responsibility of this transmission utility to develop and maintain the required technical planning studies for evaluating the impact on the grid of any proposed connection or a modification. It could be a proposed connection, new 500 megawatt solar plant or 300 megawatt wind farm, or modification to an existing connection. Already there is a connection, existing connection, you are modifying it. So we are talking purely on the wind and solar at this moment, but this study, Saudi Arabia grid code, is not exclusively for wind or solar. It is a common grid code. So which means this is applicable for conventional synchronous machines also. So we'll go through this and we will understand. But this gives a very clear message. It's a responsibility of the transmission system provider. It's the responsibility of a transmission utility. It's the responsibility of that regulating authority of this transmission network to study the impact of the proposed connection or modification in the connection on grid, which means that is this document, right? Like means if you're connecting new solar plant, new wind farms, new thermal power plant, new hydro plant, even if you're connecting maybe a steel industry, what are the studies which you need to perform? It's a responsibility of the transmission system provider to have a clear-cut guidelines of what is needs to be done. Providing this as a open document so that the person who wants to connect with this transmission system obviously follow all this protocol. That's the reason why this is very open. Is this applicable for a consumers? Not really your home, but it will be applicable for the consumers, large scale consumers. Say example, if I'm putting up, for large scale steel industry, or I am connecting a traction substation to the grid. Do we need this? Essentially, like I cannot connect a steel industry which has an arc furnace which injects a heavy harmonics to the system without impact study. Like I cannot directly connect the steel industry to the grid. Right? So is it applicable to consumers? Yes, it is applicable to consumers. Is it applicable to the sources? Yes, it is applicable to the sources. But like then is it a question like is the individual customers means like individual homes, houses, whether they have to obey? Probably means they are not really connected to the transmission utility. They are connected to distribution utility, and what is their impact is small. And probably there is also responsibility of this transmission system provider. If you have exceeded this and this and this, then probably you have to study this, something like that. Which means a consumer who consumes only maximum demand of 5 kilowatt in a household need not really do any study. Probably means to say if a consumer, commercial consumer, probably if he is consuming at like 415 volt 3-phase system and maximum demand is 50 kV or something, like he will be has to maintain this power factor this much. That's a grid code compliance. Either you perform a study or you maintain it, like that's an altogether story, different story, but like that's grid code. But you may not have such a things for your individual homes, but like definitely 50 kilowatt consumer, commercial customer definitely has power factor requirements. So that's kind of probably the regulation which is coming from this grid impact study. If the power factor of 50 kVA consumer is too low, then that will create a voltage drop in the distribution system, which is not acceptable for a distribution utility. I guess Anurag, that's clear. The next question, is it applicable for islanding? That means like islanding, I am probably trying to understand it in a different word. Is it applicable for a standalone system rather than saying it is an islanding? That means if I am not connecting to the grid, then obvious like it is not really needed, because as long as you are putting something, still from the safety perspective you have to meet the country requirements, but probably from technical perspective at the end of the day you are going to feel the heat. So it is your requirements, you need not strictly obey this, you need not really perform a study, but you have to do the study, or probably you have to do the applicable studies to take care of your system. Grid code compliance and grid impact study, same 500 megawatt I am connecting it in India, which has 400 gigawatt installed capacity. I am connecting the same 500 megawatt solar plant, probably in a islanded system in Australia, which has only 2,500 megawatt installed capacity. Do we think that my requirements will be the same? Definitely not, right? Why? Probably this 500 megawatt, 0.5 gigawatt added in Indian grid, hardly nothing compared to the existing installed capacity, but probably means for when 2.5 gigawatt, like 2,500 megawatt system, if you're adding 500 megawatt solar, it is like 20%, right? So what I mean by that, so your study varies, depends upon what's the existing system and what is the capacity of the proposed equipment. And is it going to be the remain same? Absolutely not. Probably when I have started my career in power system in 2006, wind farms are modeled as passive devices, negative loads. Let me repeat my study. Probably by the time 2006, when I have started my career in power system studies, I myself personally model the wind turbine generator as a negative load, without any inertia, without like LVRT studies, like, and probably means all the power evacuation studies done by them or done by me has been approved. By the time in India, the renewable installed capacity is nothing. But today, India has more than 27% of installed capacity from renewables, which is intermittent in nature. Shall I apply the same grid code which I have applied in 2006 to 2022? Absolutely not. So what I mean, grid code compliance study is ever evolving requirements. That's the reason why this, I mean, so to say, transmission system operator also trying to upgrade this on a daily basis. LVRT was not a requirement for the wind farms before 2006-7 in India. That's the reason why type 1, type 2 wind turbine generators are quite popular in India before that. But after that, means what say LVRT is made mandatory thanks to probably blackout somewhere in the world. Why that has been imposed in India by the time itself? Because by the time like wind started growing, and personally people afraid of if some fault somehow happens in 400 kV or 220 kV, if the wind farms get disconnected together, that may have an impact on the grid frequency. Then obviously you need to ask the wind to ride through the low voltage, right through the fault, right through the over frequency or under frequency. That's the reason why like the new requirement came. So what I'm saying, whether it's a grid impact study, grid compliance study, whatever you name it or call it, so it depends upon what's the existing system you have and what's the element which is added or modified, what's the comparable percentage of this, or what's the impact this is going to make to the existing system. Like it, that needs to be discussed or decided by this grid code, and this grid code is ever evolving because my grid is also ever evolving. Means we do not have any power electronic devices in our grid maybe before 2000, or probably means was less than 0.1% of the components are power electronic devices before 2000. I do not know, like means was say what's the percentage will be in 2015 power electronic devices. It will be much more. Like there is amazing topic, means if I replace every synchronous machines by means what say inverter based equipments, what will be my impact on the short circuit current, what's the impact on my inertia? Obvious. That's the reason why like means weak grid of Australia is probably like everybody claims that AMO is like means what say they are asking all this nonsense and this, it's a tough call, like nobody can do that, etc. But like they genuinely care about their systems, and for such a weak systems all the studies are needed, and that's the reason why they are testing. So what I mean by that, you need to understand not only from your independent power producer perspective, but also from the holistic grid operation perspective, what's the impact of the new connection which is going to make, wherever it is going to make, then probably means also you have to study this. So whether it is an impact, connectivity, or compliance, whatever you call, at the end of the day, what's the requirement, why that requirement is needed, that is the most important question rather than the terminologies. TSP shall specify which of the planning studies described of the chapter 3 will be carried out to evaluate the impact of the proposed user development on the grid. So this is another beauty, right? Means it's a responsibility of the TSP shall specify which of the planning studies, not all of the studies described in 3.36. That's the reason we are telling. Say example, if somebody is connecting 10 megawatt solar, what are the studies needed? Maybe different. If he is connecting 100 megawatt, the studies might be different. If he is connecting 1000 megawatt, the studies might be different. List down all the studies. Then based on the capacity, based on the voltage level, based on the short circuit level, based on the strength, based on the inertia available, based on the what's the complication of the technology which is going to come, probably specify what are the studies which you need to. And probably even today in India, about 15% of the wind farms are operating without LVRT capabilities. Let me repeat the statement. Even today in India, 15% of the existing wind farms which has been installed probably before 2000 is operating without means was LVRT capabilities. Like thanks to like new technologies like type 3 and type 4, the recent wind turbine generators are coming with LVRT, but like whatever they installed like much earlier is not really having this LVRT capabilities. and our system has to continue to run for at least next 10-15 years till this wind turbine generators retire. The system has to withstand and it has to take care of the existing also. And probably you might be aware of this one, like I mean, so say when we keep adding the solar, there is a famous word duck curve, right? I'm not really sure how many of you hear this word duck curve. If you hear, what is duck curve? So let's probably take maybe paint y-axis and maybe time in x-axis, draw it for 24 hours, draw it in 24 hours. Here, like demand, I'm just taking Indian example, you can probably use any other example. This is time, assume it is 24 hours, so which means like this might be 6 a.m, this might be slightly here, might be 12 p.m, here it might be 6 p.m, this is again the next day morning 12 a.m. The load is not really going to be the same. So what we mean, probably if you draw the load curve of India, probably midnight, this is previous night 12 a.m, right? Up to 6, the demand will be like less, and like it goes high, and probably means it might be stable, and probably means 6 o'clock this goes like this, and it probably comes like this. This is what probably the load curve, and of course here and there will be fluctuations, but like this is pretty much the load curve of India, probably 10-15 years back. Why I mean by that, probably by the time India, like the domestic demand after 6 p.m. is the peak demand. But if you look at the recent, I mean, so say when we have crossed the 200 gigawatt demand, 204 gigawatt demand, our peak has not come at 6 p.m. or 7 p.m. But whereas that came here in the industrial hours. That's the reason why probably at least demand is not really something like this. Okay, fine. So what I mean by duck curve means was that this demand, assume that this demand pattern still exists, but it is not the case of demand as of now in India. Now, if I draw the solar power output, this will be something like this, right? Solar will not generate power before 6 a.m. or 7 a.m. and probably it generates and probably it will reach peak and probably it will come down probably before 6 p.m. Now, means what to say, this minus this is the demand which has to be met. The demand minus solar power, like of course I am exaggerating this graph, showcasing that like means to say 30-40% of the demand is met by solar, but we have not really reached that position, right? Like at max we are able to maybe meet about like 20% in the daytime on the peak demand, even not that, like not even 20%, maybe 15% at max at an instantaneous power which we can meet by renewables, right? So but showcasing this diagram now, like what happens, like I'm precisely looking at this hour at least, the solar is not probably dropping or the solar power is going down after 5-6 p.m. and whereas at that moment, like means what to say, your demand is increasing if your country is predominantly means what to say, domestic load dependent country, like that means it's not the industrial customers but like the domestic consumers in homes, then like it gives a message, the generators which are controllable, the generators which are has to balance the generation and demand, has to ramp up at this time, right, to offset the decrease in the solar and offset the increase in the demand. And that's where what you have seen is a duck curve, right? Like you can see here, what is this duck curve, right? Your sources has to probably means controllable sources has to ramp up, and probably this takes the shape of duck curve. So that's the reason why like people's claim like they're putting image also, right? Duck curve. So this is where probably your ramp up is needed, right? When your solar is not really like the installed capacity is not this much, though it takes shape like this, assume that like if it is like this, then this impact will be different on the duck curve. And like when the solar is growing now, like we are aiming for 100 gigawatt solar by still December 2022. By looking at all this, I mean, so to say, the impact necessarily has to be studied. So ramp up, ramp down, why the battery energy storage systems are proposed along with the large scale solar plants nowadays, all thanks to like such I mean to say pre-understanding on how our system is going to happen. So coming back, so what I mean, so there are like you can list down whatever maybe the studies which is there in 3.3.6. Let's look at what is there in 3.3.6. But it is not necessary that all the studies has to be performed for even a smaller capacity or when it is connected to the stronger grid. Say example 300 megawatt connected to a stronger grid of 400 kV system which has a short circuit current of 35-40 kiloamps is completely different. The same 300 megawatt is connected to a weak 220 kV line which has a short circuit current of only 3 kiloamps or 4 kiloamps. Right. So all these things has to be properly described. Means what say what are the studies to be carried out to evaluate the impact has to be also informed by TSP. The customer who is implementing or installing independent power plant may not aware like what's the impact of his solar plant or a wind farm on the grid. That has to be specified by TSP. Like I guess like the same point they are stressing on the next, based on the magnitude and complexity of the proposed user development. Magnitude, that's obvious important, and magnitude alone important may not be. Like 500 megawatt wind farms, the type 3 might be completely different from 500 megawatt of type 4 with respect to the power quality. Type 4 may be having like a different harmonics level and type 3 will be having a different harmonics level, right? So based on the magnitude, that is capacity, whether it's 300 megawatt or 500 megawatt or 750 megawatt, depends on the complexity. When I say what's the technology, what's used in the proposed development of the user, TSP may need to conduct more extensive planning studies. So here, these are the studies to be done by TSP. How TSP will do? TSP will ask your model, like means India. Nowadays, I could see like quite a lot of people are trying to implement or install or sell PPC, power plant controllers, for a solar farm, wind farm. And as soon as like they are proposing power plant controllers, means also POSOCO is asking, give me the PSSE model, give me the PSCAD model. Equipment suppliers are getting angry on POSOCO. Why? I am installing it in my plant to control my plant. Why you asking that model, this model? Because they are not even aware what is this PSSE model or a PSCAD model. So why it is needed for, I mean, so say TSP? Because first, they are not aware how we are going to control your system, but your magnitude is heavy and the complexity is important, and that has an impact on the grid. So obviously he has to get your model, the independent power producers power plant model mathematically to accommodate in his overall system to perform the studies, right? So this extensive planning study, not necessarily a steady state study, it could be like a transient stability also, right? Why do we need to or why independent power producer has to submit their models even after they are performing the same studies in India at least, is because the study has to be repeated by TSP, right? So you are studying from your end, the independent power producer end, concluding that you do not have any impact to the grid and applying for the grid connectivity. But it is just not that the transmission system provider has to evaluate this for many other cases. That's the real reason why he is asking the PSSE model as well as the PSCAD model. So to perform the study on his own. And performing the dynamic transient studies is already there, probably means it's an implementation issue rather than whether it is existing or not. It is existing in India, but at least it's not I mean, so it's implemented properly. That's what I would say. So the user shall indicate whether it wishes the TSP to undertake the additional planning study. The user shall bear the full cost of the additional planning studies. And probably this is a Saudi policy, but in Indian policy is different. That's where the country to country varies. There, like means they themselves will do the study, TSP, but in India, it's the responsibility of IPP to perform a study, and IPP will appoint a consultant, and the consultant has to get the money from the IPP. So obviously he will say like everything is within the limit, and that brings another challenge for a TSP. In Saudi Arabia, probably means to say they are getting everything and they are performing the studies. So means to say they will be very clear and they will be like studying the impact of your system with respect to like what is the criticality for on their system. But unfortunately, here in India, the study has been done by the consultant appointed by the independent power producer, and that more or less supports obviously independent power producer, may not be the DSP. So that's also a real reason why somebody has put up like means to say 2000 megawatt is lost, 2500 megawatt is lost in Rajasthan. Like means to say as soon as the wind season starts in Tamil Nadu, means all the wind turbine manufacturers will start crying, because means to say the utility will start curtailing the wind power, right? And people's means what say peoples will say means what say power, they are curtailing power, but they have to also understand what are the constraints from the transmission system operator. Since electricity cannot be stored, the generation and demand has to match at each and every moment. It's a responsibility of this dispatch utilities to manage the generation and demand. When you inject heavily and when you reduce it drastically, somebody else, some other source has to meet this mismatch and the dynamic response. That's the reason why like the large scale solar plants will have certain, I mean, sort of say constraints on like a ramp up or ramp down capabilities. If you take like Japan grid code, you cannot increase or decrease the energy produced more than 1% every minute, which means if you're generating on an average 100 megawatt this minute, next minute you can go to maybe 99 megawatt or 101, you cannot go beyond it, which is technically not possible in wind and solar. And then obviously they need to go with the battery energy storage systems or some other energy storage system when they come to this large scale solar plants, right? Why? Their grid is weak and that is mandatory for them. Few countries has specifically mentioning few softwares, predominantly for like load flow, short circuit, stability, LVRT, HVRT, and similar studies for an RMS studies. Most of the countries uses PSSE, most of the countries including India. And probably means what see Australia is the country probably which came up with the requirements on PSCAD like long back because of their, I mean, was a constraint in their network. And nowadays, few countries started probably following up. I mean, was a PSCAD also, though whether they are aware or not aware, like, but they are asking. Countries like Oman, if you take, I mean, so they go with the DIgSILENT power factory, and even I am also a big fan of DIgSILENT power factory personally. So, I mean, so say whether it is a software specific, it has to be a software specific, because means what say utility cannot use a different softwares just because the different independent power producers are using a different software. Like tomorrow, if I'm going and putting up a 300 megawatt plant, means what say in order to make it easy and in order to bypass something from the utility, I will try to develop my own software. I will use a software which is not really available in the market. So every time probably this utility cannot change the software. So more or less all this TSPs has, I mean, what say concluded with some specific software for them, and probably you have to give I mean the file in the same format only. It is PSSE and PSCAD in India and in Australia, and most of the countries are okay only with the PSSE software. That means they are not asking PSCAD. But as I told, like if you take Oman, they are going with the DIgSILENT power factory, and Australia also, like few part of the Australia is asking DIgSILENT power factory, few part of the Australia is asking PSSE, and so forth. I mean, so say since 2000 up to maybe 2013-14 till 2012 grid blackout in India, MyPower, an Indian developed software, is probably quite famous for all this. I mean, so say power evacuation studies for wind farms and solar farms. And after that, like means was a PSSE has occupied that space, and probably means was say that almost eliminated the business of the software MyPower in India. That's like means was say like uniformity is needed, but at the cost of what? Maybe another different question to be asked. USA uses PSLF. Yes, hear it from somewhere. That's right. Means what say that's obvious again. Means PSSE is a Siemens software, German-based company. PSLF is from GE. GE is a US-based company. Enable the TSP to carry out the necessary detailed grid impact studies PSP may require the user to provide some or all the detailed planning data listed in A3.2. Chapter 3 planning code ahead of the normal time scale shown there. Saudi Arabia, they are collecting this data from the independent power producer, some or all the detailed planning data which is listed here, and they are performing the study. In India, it is the other way around. Means utility is giving their model, and probably means was that they are asking you to include your model and perform the studies and submit the report as well as submit the model. That's what the Indian context. A user applying for a new or a modification of an existing connection to the grid shall take all necessary measures to ensure that proposed user development doesn't degrade the grid. This is most important thing. Why this utility has to perform the study? The modification or an addition should not degrade the grid in any perspective. It could be a power quality, it could be voltage fluctuation, it could be a frequency fluctuation, it could be voltage stability, it could be a frequency stability, it could be like robustness of the system, etc. Right? And probably you might be aware of like 2012 blockouts and stuffs in India. I'm able to check with respect to maybe Indian this one. Let's see. We have the document. CRC also has the document, right? Yeah. This one. And I guess like that takes quite a lot of time to open, maybe 129-page document, but that's like not really to miss. You can go through this. So why I'm asking you to go through this, because you can understand like why such a blackouts are happening, and probably German blackout, thanks to this wind farms, that's probably brought this LVRT, such things which you need to understand why this, why such things are coming up. Going back to the grid codes, so the user applying for a new or modification should ensure that that doesn't degrade the grid from all perspective, and like so and so protocols, like you can go through this, and of course each and every line which is there in this report has been written with some really important aspects behind it. So connection code, like in that grid connection procedure, transmission system performance, like frequency variations, voltage variations, harmonic distortion, voltage imbalance, right? So one of the recent harmonic measurement what we had in one of the plant, that's a 250 megawatt solar plant, and like 3 numbers of such solar parks are there connecting to a common substation of 220 kV, which means like about 750 megawatts. And though this plant do not inject a heavy harmonics, but thanks to the other 252 numbers of 250 megawatt, like this is facing a problem, right? So when you are probably putting such a clusters of solar farms, that too probably from different independent power producers, different EPCs, and your task will be hectic. If there is something wrong happens, it's only a blame game rather than trying to find out like who or like what is the real reason behind it. So what's a transient voltage variations? This are all something really we need to look at, and what are the voltage variations which is allowed, and your equipment should capable of withstanding that voltage variations. Necessarily your equipment should not cause this variations. They should not be the root cause for this variations, right? Or probably means when you're ramping up or ramping down from like 0 to 100%, like what's the impact on the voltage is not only dictated by your capacity, but also dictated by the source impedance. That means also dictated by what is the short circuit level of the 220 kV substation which you are connecting. 220 kV, I'm just giving an example. That could be any number, depends upon your capacity. So you need to ensure that your ramp up, ramp down should not have an impact, adverse impact on the grid voltage fluctuations, right? And the harmonic distortions, like predominantly people will talk about like, even you look at this, right? What is wrong with this statement? This is a grid code, which is like you're looking at 2.4.4.3. After reading the statement, what is wrong with that? Can you say something? What is the wrong with statement 2.4.4.3? Probably when you are choosing. So IEEE 519 1992, IEEE 519 2014, 2014 has a completely a different requirements of, right, voltage distortion limit. This is IEEE 509 2014, which I have opened, and it is IEEE 509 1992. But on anyway, like look at this, maybe current, this may not actually matches with the current distortion which is probably specified here, right? And unfortunately, like even the grid code which is coming in 2022 February is still recommending maybe IEEE 509 1992, because means you may need like a multiple experts from different aspects has to be there to frame this code. And probably means what say, now the technology is growing at much faster pace than probably the grid codes can develop, or much before the standard comes in, probably the technology is going to the next level, and we cannot probably able to really put up a standards or a regulations or something. That's because like the technology is like faster than like what we can do with respect to I mean, so say this grid codes or something like system services with respect to the frequency control, what your new element has to do with respect to voltage control, with respect to system control, what it has to do, and means was with respect to the contingency, what it has to do, how it has to be tested, right? Means was a LVRT, whether I have to simulate it in PSSE, whether I have to simulate it in PSCAD, or whether I have to test it at site, right? And you might be aware of R1 and R2 testing in like Australian market, where something has to be tested at site and that has to be proved with plus or minus 5% error with respect to the simulation what they have made, right? So all these things has to be there as a part of the grid code, and such a things may not be really needed as long as probably the grid is strong, and still I mean, so to say, this one is means to say the considerable renewable penetration is not there in the market, right? So this all this probably gives like means to say what are the protections needed and stuffs. But like I'm going to maybe looking at one important aspect, right? Requirements for generators. So this, since it's a common code, this gives the requirements of like synchronous machines as well as power park models. Power park models could be like solar inverter or a wind turbine generator. Synchronous generating units shall be capable of supplying rated active power output at any point between the limits of 0.85 lag and 0.95 lead. So in order to meet this, you need to optimize your generator transformer impedance. You need to optimize generator transformer OLTC range. You need to optimize the I mean, what to say, generator power factor. Like this limit ensures that irrespective of the capacity, you need to ask the generator rating as 0.8 power factor lag. Else, like you need an additional excess means was say separate reactive power compensation. So this decides like three aspects. What's the OLTC range of your transformer? What's the impedance of your transformer? That impedance decides what is the generator circuit breaker rating, and of course, I mean, so to say, this also dictates what's the reactive power capability of the generator, or means what to say, what's the power factor of the generator on the lagging one. It is at generating unit terminals unless otherwise agreed expressly by TSP. So what they are asking is, where is another question to be asked, whether it is at generator terminal or at point of connection, right? Like here this grid code asks generator unit terminals. So this is where another beauty comes. If you're asking at point of connection, that's a different story. If you're asking at generator terminal, that's a different story. Why? If you're asking at point of connection, like your transformer impedance has a role, but here they're asking at only generator unit terminals. So like it's not a problem. Say example, if you take the transformer, generated transformer impedance, step up transformer impedance, maybe for like example 100 megawatt plant in India, the impedance will be in the range of about 10-12.5%. If it is in Singapore, percentage of the impedance is like 25%. What's it mean? 25% of the MVA rating is lost as a reactive power in the transformer itself, which means even if you're generating 60 MVR, 60 minus 25, only you will be able to inject 35 MVR to the grid at 66 kV in Singapore. That cannot be more because they limit what's a short circuit current which you can inject to the 66 kV system. They will not allow more than 1 kiloamps at 66 kV. Then it is essential you have to go with that impedance. If you go with that impedance, obvious there will be reactive power losses. So here DIALux at least they are asking at terminals. So your transformer impedance or transformer OLTC may not have an issue, but if you are asked that point of connection, then there will be definitely an impact, right? Like that's for synchronous machines. Let's come to this power park models. That's an inverter, solar inverter or wind turbine generator. Models shall be capable of absorbing or supplying reactive power output at the connection point. Look at these words, like this is where the beauty is. Here at connection point, here at generating unit terminals, not at the connection point, right? And look at here, connection point within the range of minus 0.33 to 0.33 of rated active power. It is 85% power factor lagging and 95% power factor leading at the generator terminals. When we say 85% power factor and 95% power factor, this is Q proportional to P. But here Q minus 0.33 and plus 0.33 not proportional to P. It is a fixed number with respect to the active power. And I guess like the graph says clearly this. When we say 0.85 lag, this is much like y-axis, what you have is real power P, and x-axis you have like a Q. Means what's the, if I am going like this, like what's the power which I need? Means what's the Q increases with increase in P, Q increases with increase in P, both on lagging mode and leading mode. That's the blue one is for synchronous generating units. But when it comes to the power park models, wind turbine generators and solar inverters, what happened? You can see the red box. The requirement might be less because here it is 0.85 lakh, here it is 0.33 corresponds to only 0.95. But that 0.95 is not really constant. Q by P max is a constant. You need to maintain 0.33. The reactive power is 0.33 per unit of the rated power, even if it is generating only 20% of the power. When the power is reduced below 20%, then it has to be like 0.05 per unit to minus 0.05 per unit. If you want to test all these things, definitely you need a power plant controller. Like if I'm going for a 250 megawatt plant, if I'm going for central inverter with even 5 megawatt inverter, like I have 50 inverters. If I'm going with 2.5 megawatt inverters, I will be having 100 inverters. If I'm going with a string inverter of 250 kilowatt, you can assume like how many inverters I need, right? I need 1000 inverters. I cannot control individual inverter. I need to study all this thing probably with the help of power plant controller, and this power plant controller is required to be modeled if you want to study these impacts, like in dynamic studies. Right. So it gives probably clear understanding. And again, like one more thing which is not really visible here in this image, this blue line is at the generator terminal, whereas this red line at the point of connection. That means this red line has to be met at like your point of connection 220 kV or 400 kV, whereas this has to be met at your generator terminal. Right? Meeting something generator terminal might be easy because you may not have a reactive or loss in the transformer. If you need 0.85, like means what say, like that could be like one important aspect which we are missing. But if you are a load, carefully watch my sentence. If you are a load, if you are consuming power from the utility, if they are asking you to maintain power factor of 0.9, which means they are expecting a minimum power factor of 0.9, which means you have to maintain a power factor of 0.9 and above. If you are a source injecting power to the grid, if they are asking you to maintain a power factor of 0.85, which means your power factor has to be 0.85 or less, which means your reactive power capability is capable of supporting that much reactive power for whatever may be the application which is requested by the grid. So 0.85 or 0.9 power factor of load has to be proved in the simulation, with proving that the power factor is more than that, and reactive power requirements for the sources has to be proved with a power factor which is less than this, which means which is capable of supporting that reactive power. Means so the transmission operator is the guy who is responsible for regulating this 220 kV substation voltage or 400 kV substation voltage. Means in order to, if you want to maintain the voltage, like you know, if you want to increase the voltage, you need to inject reactive power. If you want to reduce the voltage, you have to consume reactive power. So, and probably increase in reactive power or consuming reactive power, how much percentage voltage will change depends upon the source impedance. These are all the things known to the transmission system operator, and he knows what's the voltage variation allowed. He knows what's the voltage to be limited, and hence he is putting that as the reactive power requirements. And the reactive power requirements is expressed as a power factor to the independent power producer. Thank you all. Thank you so much. Have a great day.